Hi everyone, so now we're going to be talking about how to solve systems of equations by substitution. So there are three different ways that we can solve systems of equations by graphing, substitution, and elimination. We've already talked about the graphing, so now we're going to talk about substitution. When we solve systems of equations by substitution, what that means is that we're going to take one equation, solve it for one variable, and then replace the variable in the second equation with that equation and solve one equation with one variable. That was a lot of words and it probably didn't make sense, but let's go through an example and it should make a little bit more sense. So we're going to start with the first example. The first example is y equals 4x plus 11, and then y equals negative 4x minus 13. All right, so now if you notice, both of these equations are solved for y, which means that we know that y is equal to 4x plus 11, but we also know that y is equal to negative 4x minus 13. What I'm going to do is I'm going to say, well, if I know that y is equal to 4x plus 11, then if this y is equal to 4x plus 11, then this y also must be equal to 4x plus 11 because y didn't necessarily change values, right? It's still the same y. So what that means is we're going to take this 4x plus 11 and replace this y with it. So I'm going to take this whole equation and kind of wrap it around and pull it down here so that I can rewrite the bottom equation as, instead of y equals negative 4x minus 13, I'm going to write it as 4x plus 11 to replace that y equals negative 4x minus 13. And I can do that because both of these equations were set equal to y, which means I can replace one of the equations with the other. And now you notice we only have one equation, and in that one equation we only have one variable, which makes our life way easier because now we can solve this equation for x. So let's go through and solve it for x. I'm going to first get the x's on the same side by adding this 4x to both sides. And I have 8x plus 11, and then equals, the x's cancel out on this side, so negative 13. Now I want to solve this continue solving for x. I'm going to move the 11 over by subtracting. And I get 8x on this side equals negative 24. Then the last step is to get rid of the 8 by dividing on both sides by 8. And I end up with x is equal to negative 3. Okay, sweet. So we know that x is equal to negative 3, but we're not done yet. We know that x is equal to negative 3, but we still don't know what y is equal to. So when we solve systems of equations by substitution, what we have to do is get one variable, solve for one variable, then take that and plug it back into one of the original equations. So we know that x is equal to negative 3. Now I'm just going to take the top original equation, which is y equals 4x plus 11, and I know that since I know that x is equal to negative 3, I can replace this x with negative 3, which means I can write this equation y equals 4, but instead of x, I'm going to put it as negative 3 plus 11. And now all I have to do is plug that into a calculator or solve it by hand. I end up with negative 12 plus 11, and then y equals negative 1. And so now I have a solved system of equations because I know that x is equal to negative 3 and y equals negative 1. All right, let's go through another example. So for this example, we have y equals 5 and 7x plus 6y equals negative 5. This one's kind of almost like a special system. Not really, but it's a little bit of a special system because we already have one of the variables solved for. We already know, they already told us that y is equal to 5, which makes our job easy because now that I know that y is equal to 5, all I have to do is plug that into the second equation and then solve for x. So I'm going to rewrite the second equation, 7x plus 6y equals negative 5, but we know that y is 5, right? So I'm going to erase the y in this equation and replace it with 5. And when we replace it, we put it in parentheses just so we know that it's not 65, it's 6 times 5. Okay, so now all we have to do is simplify and solve this. So when I simplify it, I'm going to multiply the 6 and 5, which gives me 30. Then it's just a simple equation that I can solve by subtracting 30 from each side. We get 7x equals negative 35. Then we divide each side by 7. And we get x is equal to negative 5. All right, and actually we're already done. Even though we only solved for one equation, one variable, the other variable is already right here. So we know that this system of equations, x is equal to negative 5, and y is equal to positive 5. All right, let's go through a couple more examples. For the third example, we're going to say negative 6x minus 3y equals 57, and y equals negative 2x minus 19. Okay, so unfortunately, this one, both of them are not solved for y, which was like the first one, and one of them isn't already solved for, so like for a number. So what we're going to do is we're going to actually take this bottom equation because it's already solved for y, and we're going to replace the y in the top equation with it. So this y right here gets replaced by this because the y's have to be the same, right? So if I know that y is equal to negative 2x minus 19, then this y right here also has to be equal to negative 2x minus 19. So I'm just going to rewrite the top equation, but instead of putting y, I'm going to write in negative 2x minus 19. All right, now we're going to simplify and solve. So the first thing we're going to do is distribute this negative 3 inside the parentheses. We get negative 6x plus 6x because the negatives cancel out, plus, and then 3 times 19 is 57. And then actually, so we have negative 6 and a positive 6x on this side, and they cancel each other out because a negative and a positive of the same number equals 0. So now I just have this equation that says 57 equals 57. Now, does 57 equal 57? Yes, that makes sense. 57 is equal to 57. When I get an equation like this, that they're equal, that the right side is equal to the left side, and there's no x's or the x's have disappeared, that means my answer is all real numbers. I don't even have to solve for the x or the y because no matter what I plug in, it's always going to give me the same answer, or it's always going to give me the same thing on the left side and the right side. The other option for this, or the other special system, is if I were to have gotten something that wasn't equal to each other. So if the x's cancel out and I got like 6 is equal to 57, well, 6 isn't equal to 57. And if that was the case, then your answer would be no solutions because that doesn't make sense. Okay, one more example. And this example is negative 3x plus 7y equals 12, and negative 2x plus 4y equals 6. So neither of these are solved for a variable. And when this happens and you want to use substitution, the easiest way to do it is to pick one of the equations, and it doesn't matter which one, whatever one looks easiest, and solve that one for either x or y, and then plug it in. So what I'm going to do is take the bottom equation and solve it for y. And I'm just going to rewrite it over here so we don't get super confused. So to solve this for y, the first thing I'm going to do is add 2x to each side. And I end up with 4y equals 2x plus 6. Now I want to get rid of the 4 in front of the y, so I'm going to divide both sides by 4. And I end up with y is equal to 2 divided by 4 is 1/2. So I'm going to write 1/2 x. Then 6 divided by 4 is 3/2 plus 3 over 2. Unfortunately, we're going to end up with fractions, but it'll still work out. So now I have this equation solved for y. What I can do is replace this y right here that I just underlined in the top equation with the y that I just solved for, because those y's are the same. So I'm going to rewrite the top equation now, negative 3x plus 7, but instead of saying the y, I'm going to say the thing that I just solved for. So the 1/2 x plus 3/2, and that's equal to 12. All right, now we should be able to solve this for x. The first thing I'm going to do is distribute the 7. It's going to start looking real yucky here, but I promise it should work out in the end. We got negative 3x plus 7 times 1/2 is 7/2 x. 7 times 3/2 is 21/2 equals 12. Now we're going to combine the like terms. So we've got negative 3x and 7/2, and then that gives me 1/2, positive 1/2. So I'm going to change that to be positive 1/2 x plus 21/2 equals 12. Now we want to get the x by itself. And the way we're going to do that is by subtracting the 21/2 on each side, which would give me 1/2 x, and then 3/2. And you can use your calculator for this, obviously. And then the very last step is to get rid of the 1/2. To get rid of the 1/2, we're going to divide by 1/2 on each side. The other option on this is to multiply by its reciprocal because it does the same thing, but we'll just divide by 1/2. You get x, and then that's equal to 3. See, I told you it would work out. So we know x is equal to 3. Great. Now I need to find the y. So to find the y, I'm going to go back to one of my original equations up here and plug in the 3 for x. So I'm just going to take that bottom equation just because it's a little bit smaller numbers. We've got negative 2x plus 4y equals 6. But now I'm going to replace the x with what I know it is, and which is 3. Okay, so now we're just going to simplify and solve for y. We've got negative 2 times 3, which gives me negative 6 plus 4y equals 6. I want to get y by itself, so I'm going to add 6 to both sides. These 6's cancel out. I'm just left with 4y right here, and I get 12 right here. Then I'm going to divide both sides by 4. I get y is equal to 3. So I have x is equal to 3 and y is equal to 3. And that is how we solve systems of equations.